Hey, good morning, class. It is Wednesday, April 29th. Mr. Coates here to go over your learning targets today, okay? Every Wednesday, we'll have our Zoom meeting at 11:30. I've told some of you that's my favorite part of the week to look forward to seeing you guys on Zoom. In IXL Math today, I'm going to teach you about an improper fraction and a mixed number, how to change them back and forth between each other, and you'll get a chance to practice in P24. And in science, we're going to continue our focus and study on weathering and erosion. Today in Mystery Science, how could you survive a landslide? We'll look at some examples of that in Mystery Science. But first, what is an improper fraction? The definition of an improper fraction is a fraction in which the numerator is greater, that means bigger, than the denominator. Example, the numerator here is 7. Denominator 4, 7/4 is an improper fraction. So here you can see a picture or illustration of 7/4, 7 parts shaded all together. All right, so now let's look at our definition of a mixed number. A mixed number is a number consisting of a whole number mixed with a proper fraction. Here's an example, 1 and 3/4. 1's the whole number, 3/4 is a proper fraction. And so here I drew another picture to show an example of 1 and 3/4. So now what do you notice when I put these two side by side? 7/4 compared to 1 and 3/4. Well, I'm sure you noticed that 7/4 is actually equivalent to 1 and 3/4. It's the same exact amount that were shown in both illustrations. It's just 7/4 is named as an improper fraction and 1 and 3/4 is named as a mixed number. But they are actually equivalent fractions. So in today's IXL lesson, that's exactly what you'll be working on. Here is an improper fraction. You'll notice right away it's improper because 29 is greater than 3. Remember, the definition of an improper fraction is a fraction which the numerator is greater than the denominator. So how can we turn this improper fraction into a mixed number? When I look at this, I first think, how many thirds does it take to make the number 1? Well, I know 3/3 makes one whole number, so that means another 3/3 makes two whole numbers. So if I combine these together, that's 6/3. That's an improper fraction. But if I pull them out or decompose them, that's 3/3 and 3/3, which is 6/3, but it's also equivalent to 2 whole. All right, so if we keep going, that would be 3 whole. If you add all those, that's 9/3 plus another third. You see, we're just going to keep adding these up until we get close to the number 29. And at the very end, if we decompose 29/3 over and over and over, we're going to end up with this all together plus an extra 2/3 will totally add up to 29/3 if you were to continue adding those up. And that's an improper fraction. But now if we go back and look at each one of these as a whole number, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 whole numbers, and 2/3 altogether makes the same or equivalent to 29/3. So 29/3 would be the improper fraction, 9 and 2/3 would be the mixed number. Let's look at a simpler one. Let's write 5/2 as a mixed number. So I'm going to decompose 5/2. So 2/2, makes one whole. Another 2/2 makes another whole. So far I'm up to 4/2. So I would need another 1/2. All decomposing this 5/2 would then add back up to 5/2. So breaking it down, 2/2 plus 2/2 plus 1/2 equals 5/2. But now if you go back and look at this is one whole. That's another one whole. So we have two whole numbers and another half, and that is equivalent to the improper fraction 5/2. Now I'm going to use this same fraction, 5 halves, and show you another strategy. Basically, when we look at a fraction like 5 over 2, this bar here is actually a division symbol. That's right. We can look at a fraction like it's a division problem. So we've seen division problems using this symbol. We've seen division problems using this symbol. Well, now this can be looked at as a division problem. Let me show you. The numerator would be the dividend inside. The denominator would be your divisor outside. So now you have a simple division problem. How many times can 2 go into 5? Well, that's 2 times. What's 2 times 2? That's 4. Subtract, and you get a difference of 1. That difference becomes your numerator. This divisor is your denominator. So there you have 2 and 1/2. And if you remember, that is equivalent to 5 halves. Well, let's try that division strategy on this improper fraction. So I have 59/8. So I could decompose this. I can say, oh, out of 59/8, there's 8/8 plus another 8/8. And I can go on and decompose that, right? Let's see what I would end up with. So look at, I have decomposed 59/8, one whole number at a time. That's 8/8 and another 8/8. That's 16. Another 8/8 makes 24. Another 8/8 makes 32. And we can keep going up to 40. That's 48. That's 56. So I'm at 56/8 already. And if I were to tally that up and then add the other 3/8 here at the end of my equation, that's a total of 59/8, right? So we can put those pieces that we decomposed back together to make 59/8. And then we can go back and count all the whole numbers. We have 1, 2, 3, 4, 5, 6, 7 whole and 3/8 left. So let me write that down. We have 7 whole and 3/8 would be this fraction. But I think the division strategy I just showed you would be a little simpler in this case. So we'd have 59, which is the numerator, goes inside your division problem, and we'll divide that by 8, okay? So I'm simply going to ask how many times can 8 go into 59? 8 goes into 59 7 times. We know 8 times 7 is 56. Subtract, we'd have a difference of 3. Remember that remainder can be known as your numerator now, and 8 is what we're working with. So there you have it, 7 and 3/8. It is equivalent to 59/8. Another strategy for you. So now we have a mixed number, 9 and 2/3. We need to write this as an improper fraction in this particular example. So we're just going to work backwards. So in this case, we're going to take the number 9 whole, and we're going to see how many 3/3 can we use to build 9 whole. The reason I say 3/3 is because thirds is our denominator, and we know that 3/3 makes 1 whole. So how many of these can we build to get a total of 9 whole numbers? All right, I'm back. I did it. I made a total of 9 of these because I know each one of these is 1 whole number. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 whole numbers. That represents this number 9. And 2/3 is this proper fraction. So what if I were to keep adding all the numerators all together? So that'd be 3 plus 3 plus 3 plus 3 9 times. Well, I can think about it 3 9 times is 27 plus 2 more would make a total of 29/3. So that's the improper fraction, 29/3, which is equivalent to 9 and 2/3. All right, let's look at another example using this mixed number, 7 and 1/2. Let's try to make it as an improper fraction. Okay, so I have built all of the 7 whole numbers as a fraction. 2 halves makes 1 whole. Another 2 halves makes a second whole. Another 2 halves makes a third whole, and so on, until we get to this last piece, which is the proper fraction 1/2, okay? So I have a total of 7 whole numbers and an extra half to build 7 1/2. So as an improper fraction, I would just add up all my numerators. Well, counting by 2s is fun and easy. Let's count. 2, 4, 6, 8, 10, 12, 14 halves makes 7, plus another half makes 15 halves altogether. So we can write 15 halves is equivalent to 7 1/2. Okay, but I also have another strategy that you can use for this one as well. I think it's a little bit easier. If I need to change this mixed number, 7 1/2, into an improper fraction, I would simply do this strategy because I know 2 times 7 is basically what I did here, 2 times 7. So I would follow this pattern. 2 times 7 is 14, plus 1 more makes 15. Do you follow that? I'll zoom in and show you one more time. Okay, so if I had a mixed number, 7 1/2, I would simply say 2 times 7. So 2 times 7 is 14, and then add the extra 1. Okay, so 2 times 7 is 14, plus 1 more makes 15 halves. That would be equivalent to 7 1/2. And your last target today will be looking at Mystery Science. In this video, how could you survive a landslide? And I have something I've been working on in my yard, so I would be happy to share that on Friday during the erosion observation video. Pretty much what Mystery Doug showed you in here, I kind of built myself at home, so I'd like to share that with you guys and encourage you Friday, if you'd like to do the same, be on the lookout for Friday's erosion video, okay? All right, everyone, that's a wrap for today, Wednesday. Your learning targets again after your Zoom meeting, IXL P24 and Mystery Science, how could you survive a landslide? And everyone, please make it a great day, and we'll see you soon.